Algebra 2, Unit 3, Day 2. Okay, today we're going to look at some more solving of linear equations. Systems of equations. We saw in Day 1 that you could have zero solutions if you had two parallel lines. You could have infinite solutions if you have the same line written two different ways. Or you could have one solution if you had two unique lines that had different slopes, but they had one intersection, so in one solution. Okay, so today we're going to look at doing this algebraically, not necessarily with a graph, and we're going to do this with the substitution method, which you used in Algebra 1. So substitution method, let's take a look right here. Remember that when you find a solution, it's a point on a graph. So you're going to have to find both an x and a y value. So your solution is going to be x comma y, like 5 comma -2 or 3 comma 0. Okay? You're going to have to find an xy coordinate pair. Okay, and it will have to work in both equations if we have two equations in our system. So for substitution, we must isolate, okay, one of your variables if it's not already isolated. Okay, now isolated doesn't have to be a bad thing. See, don't feel sad if you're isolated. It means that we are getting you away from the bad crowd and we're making you feel special. Okay, isolating means getting them all on one side. Like here's the equal sign. Okay, this guy's isolated. So if this is y equals, cool. We could also do this with x equals. So if this is our x, if it's x equals, that's cool too. All right. So we're going to isolate one of your variables if it's not already isolated. Okay, and it could be in the first equation or the second equation. That's why it says one of the 4 variables. So you'll have an x and a y in the first and an x and a y in the second. So as long as we isolate one of them, we're good. Okay, so now we take that variable and we substitute that variable in the other equation and we solve. Okay. Once you solve for that variable, okay, remember you have to get x and y. So let's say you just solved for x. If you solved for x, now you have to substitute the x back in and get your y. Okay, I think if we do one of these examples that it'll be pretty crystal clear. So let's do this one. Okay, I see right out of the bat, there's a y equals. This one's isolated. I am going to take this y and I'm going to substitute wherever that y is in the second equation. Okay, in the second equation, right? I'm going to substitute that 8x minus 6. So y equals 5x plus 9 is what we start with. Okay, but I'm going to substitute for y. So instead of y equals 5x plus 9, I'm going to substitute 8x minus 6. Okay, so it used to be y, but since y equals that, we're going to substitute that in for the y in the other equation. Okay? And now we're back to some good old Algebra 1 stuff. Now we got to isolate the x. So, you can do this a number of ways. First thing I look at, I see there's no like terms on the left, and I see there's no like terms on the right. Okay, I can't add or subtract two unlike terms. So now I got to cancel. So what I would like to do is to get all my x's on one side. So I'm going to choose to cancel the 5x. I'm going to subtract 5x from both sides. And I get 3x minus 6. And I get 0 plus 9, which is 9. Okay, now we got good old two-step algebra. Okay, you should feel right at home now. We're going to add 6. So we've got 3x plus 0 equals 15. Then the last thing we're going to do is divide by 3. Divide by 3. So I've got x equals 15 divided by 3 is 5. Okay, so I got my x value. Now I need my y value. So this is one of the cool parts. When you find one of the coordinates, x or y, you substitute it back into either equation. You can substitute it back in for this equation or for this equation. Okay, it honestly doesn't matter. Let's do the first one. So I've got y equals 8x minus 6, but I know what x is. X is 5. So I substitute the 5 where there used to be an x. And all I have to do is solve for y. So 8 times 5 is 40. 40 minus 6 is 34. So my answer is that these two lines, if I graph them, they would intersect at the point 5, 34. Okay, check your answer. Nice thing about the algebra, you should never give me a wrong answer. Why not? Because you should be able to find out if it's right or not. If it's right, give it to me. If it's wrong, go back and find what you did wrong. Okay, how do we check the answers? Well, I'm going to take this x and this y, and I'm going to substitute it in for each of the two equations and see if it works. Okay, so check in my answers. So y equals 8x minus 6. Well, my y is 34 equals 8 times x minus 6. My x is 5. My x is 5. Okay. 40 minus 6 is 34. 34 equals 34. Okay, checks out on the first line. Okay, let's do the second line. I don't have a lot of room over there, so I'm going to come over here. I'm going to go y equals 5x plus 9. 5x plus 9. Again, my x is 5. So 5 times 5 is 25. 25 plus 9 is 34. 34 equals 34. I've checked my answers. I'm going to put this into my Alex. I'm going to pass that in. I know it's right. Okay. So if we had gone back and checked and we did not get a truth statement in one or both of those two lines, we know something's wrong. We got to go back and we got to change something. Okay. Now, your turn. Hit the pause. I'm going to let you have whatever time you need, but I want you to do this one. So please pause it. I'm going to have the have my work popped up in about 3, 2, 1. Boom, and there is my work. Hopefully you took the time to do this, but I substituted for the first equation, the y is isolated, so I took negative x plus 5, and I substituted it right there for the second y. So I had negative x plus 5 equals 3x minus 7, which I wrote right here. Then I solved. Frequent mistake. Sometimes people forget that there's an invisible 1 when you don't write anything in front of a variable. So that's like minus 1x. So you put plus 1x, plus 1x. 3x plus x is 4x. That's a very common mistake, so watch out for that. Yes, when I got this answer, I did go back and check it, but I'm not going to write all that down because I'm going to keep this note session as short as possible. Okay. And our last page. Okay. Using substitution again. So take a look at this. This particular equation has x isolated. X is all by itself. Okay. So I'm going to substitute into the second equation. So I'm going to rewrite the second equation, but I'm not going to write x. Okay. So I've written the second equation, but I did not write x. I'm going to substitute I'm going to substitute 2y minus 5 for x. Okay, so now I have all y's. I can now solve for y. All right, so on the left side, there's definitely some stuff I can do to simplify the left side, so I don't have to cancel anything yet. So let's distribute 2 times 2y, 2 times minus 5. Okay, so on the left, there's still some stuff we can do here to simplify. We have 2 like terms, 4y and minus 3y. So 4y minus 3y is 1y, which I'm just going to write as y. Bring down your minus 10. Okay, now I'm going to add 10 to both sides of the equation. And I got y equals 4. Yeehaw. Okay, so now that I know what y is, I'm going to choose to go to this first equation, and I'm going to substitute y is 4 for that y. So I'm going to write it like this. X equals 2 times y minus 5. But the y, I know, is 4. Okay, I know my y is 4. Cool. So x equals 2 times 4 is 8. Minus 5 is 3. Okay, check your answer. Okay, go back in here. All right, 2 times 4 is 8, minus 5 is 3. 3 equals 3. 2 times 3 is 6. Minus 4 times 3 is 12. 6 minus 12 is negative 6. So if you go back and you check, you do get that it works in both equations. So 3, 4 is your solution. That is the point where these two lines would intersect if we graph them. Okay, so let's look at question 2. Now question 2 is the very first time that you didn't have either x equals or y equals already sitting there looking at you, right? So we have to do just a little bit of work, but not much, okay? If you see an x, especially a plus x or just a positive x, or a positive y or plus y, then that's what I'm going to isolate, okay? But we need to isolate it. So how do we isolate it? Well, let's rewrite it over here. Let's rewrite it. Let's put it up here. Negative 2x plus y equals 4. Okay, I need to get y isolated. So I got to cancel that negative 2x. So I'm going to add 2x to cancel it. So plus 2x over here. Okay, I've got those canceled. I got y, positive y equals, you can write it as 2x plus 4 or 4 plus 2x. It does not matter. If you were going to graph it, some people like to keep the mx plus b, and they would go positive 2x plus positive 4. But we're just solving it with algebra, so it really doesn't matter a bit. All I know is that I have isolated my y. I know that this is what y equals in my first equation. So that means I'm going to substitute it right there in that y in the second equation. So let's do that. So negative 5x plus 2y equals 9. Okay, so what is it that y equaled? Well, y equaled 4 plus 2x. That guy right there. That's what we substituted. Okay? All right, so let's simplify that left side. Let's take positive 2 and distribute. Okay, I bring my minus 5x or negative 5x down. Plus 2 times 4 is plus 8. Plus 2 times plus 2x is plus 4x. Easy peasy. Okay, we have some like terms over here. Got a couple of terms that have x's. So negative 5x plus 4x is negative 1x. Or you can just put negative x, whatever you like. Bring down the plus 8 and set that equal to 9. Okay, I'm going to choose to subtract 8. So I've got negative 1x equals 9 minus 8 is 1. Last thing I'll do is divide by negative 1, divide by negative 1, and I've got x equals negative 1. Okay, great. That's the hard work. Now let's do the easy work. I'm going to go right back to here. Y equals 4 plus 2x. Because I did all the isolating for y, I'm going to substitute my x into that. I think that'd be the easiest thing in the world for me to do. So instead of y equals 4 plus 2x, it's going to be y equals 4 plus 2 times, since x is negative 1, 4 plus 2 times negative 1. So 4 plus 2 times negative 1. All right, PEMDAS, order of operations, GEMS, whatever you want to call it, tells me I've got to do the 2 times negative 1 first. So 2 times negative 1 is negative 2, so 4 minus 2. So y is 2. All right, so that tells me that my answer should be negative 1, comma 2. If I graph those two lines, the lines would intersect at negative 1, comma 2. All right, so now you have your turn. I'm going to ask you to kindly pause so that you can try these on your own, and then I will have my solutions ready for you in 3, 2, 1. And here we are. Okay, so I have questions 3 and 4 done out. With question 3, you can see that y was already isolated with x minus 1. So we substituted x minus 1 into the first equation right here. We simplified by distributing, and then we solved for x, and we got 4. And then we substituted back into the y equals that we used before, and we got y equals 3. So our answer was 4, comma 3. Okay, and then the second one, we had a positive x, so I decided we were going to solve for that positive x by adding 2y to cancel the minus 2y out. So we got x equals 11 plus 2y, and we substituted that in for the x in the first equation. We put it right there. Right, then we did a little distribution, negative 7 times 11, negative 7 times positive 2y. Then we combined minus 14 and minus 2 for the y's, got minus 16. We canceled the minus 77 with the plus 77. We divided by negative 16. We got y is negative 4. And then we took that y is negative 4, and we put it right there. So we had x equals 11 plus 2 times negative 4, which came out to 3. So our solution for number 4 was the point negative 4, 3. Okay, isolation isn't always bad. We isolated by substitution. Okay, that's it for day 2. See ya.